Yeah.
Okay, so thanks for the invitation, and basically, uh, I can briefly tell you about the Annex 93, which is on energy resilience of the buildings in remote cold regions, and I'm the one of the operating agents along with Alexander. So briefly about some background, why we need this energy resilient buildings and district, for example, in the current situation. We are all aware about the emissions and greenhouse gas emissions due to human activities, and this is causing the change in the climate in the cold regions. And of course, there is kind of a increase in a lot of natural disasters and different extreme temperature, storms, or heavy precipitation. And this can cause blackouts or grid loss or something, and there are a lot of these, let's say, off-grid region as well. So we are interested in those things. And also nowadays we are looking into this energy security crisis and other elements that can cause energy shortage, and for economic stability and safety and everything. So it's kind of mix of everything that we are experiencing now. And of course, this, if something happens and then there's some, if there's energy shortage or if there's any grid loss due to any natural disaster, then there could be escalation of negative and costly cascading events in the society. So that's the bigger, let's say, challenge in this region. Uh, so as I mentioned about some of the challenges, that there is remoteness and lack of resources, for example, fuel. There could be cold waves. Then there's risk of, let's say, maintenance and high cost of maintenance, accessibility issue, and things like that. Then there are these construction challenges because the land is different, so there are these kind of challenges. And if we look into this energy security or any grid loss, then of course then the indoor temperatures can drop very fast as well. So this can have effect on the human as well. If we look on the research on this energy resilience topic, so it has been slowly growing with time. Uh, and this is from the Web of Sciences that just kind of gives you an overview of how the resilience in the buildings are growing with time. Uh, when I talk about energy resilience term, I mean there could be many different terms and different way how we use this concept of resilience. But broadly, this resilience is looking into this unpredictable factors, which could be, let's say, in terms of likelihood, maybe not so high, but then the impact wise is quite high. And then there are these other terms like stability, reliability, robustness, flexibility. So these are some of the quite common words that are being used as well. So there is overlap, let's say, in many elements, but then there are certain differences as well. And for resilience, this is like the bigger, let's say, component, or the main components or the concept level is basically if there's a building and it faces some kind of a source of disruption, for example, natural disaster or any economic situation or energy shortage or anything or any, let's say, failure in the technology, then it can cause some disruption in the services, destruction or decline in services. Then it can have an effect on the occupants or on the technical systems in the building. So basically we look into these elements and how we can cope up for any situation. So either we need to have flexible system, or we need to have agility, or we need to adapt as well. So we kind of need to make systems a bit more robust than what it is there. For defining the energy resilience, or how we kind of estimate, first we need to know about uh, resilience to what. This is one question that we need to know. Resilience for what? and then what are the KPIs or indicators, and then we do the assessment as well. So these are some of the, let's say, the bigger questions that we first need to define to go into this resilience, or to, let's say, develop our energy resilience solutions for the building. And the overall definition of energy resilient building is building that can maintain, especially during any kind of blackout or power outage situation, the indoor temperature within the habitability thresholds, and also provide the survivable conditions. So habitability basically looks into on the temperatures or the comfort, or let's say indoor temperature, and survivability looks into the other, let's say, appliances or electrical loads which are essential, for example. And the aim is to reduce the impact on the health of the building occupants, also reduce the damage to the building structure, and also look into the energy efficiency as well. And the final target is to improve the long-term resilience for any future disruptive event. So basically, we try to learn from the current situation and then improve as well. So, and that was kind of a background, and then I can briefly tell you about the Annex 93. So this Annex 93 looks into the resilience of the buildings in cold regions. So what the earlier presentation was there. So we try to look into these challenges of, for example, snow and how it affects the performance of the building, especially during extreme climate situations, heat waves, cold waves, those kind of things, and also in the power outage. And some of the main objectives that we are looking into is to identify what are the threats. We need to know the threats because these cold regions are not only in the north of Europe, but there is Canada, USA, Japan, and these regions are there as well. And we are working with all these countries in this annex. And so the main objective is to identify what are the local specification, what are the threats of these cold regions. Then we try to identify some of the case studies for the resilient buildings and communities. So what are the building practices? What are the, let's say, the energy systems as well? And what are the local guidelines? And then make this kind of a best practice or guidebook on this. This is the theory of change. So on the left, we have the problem statement. What are the problems that I was discussing before? And in the input, we have literature review, some of the stakeholders engagement, case studies, and the simulation studies and data collection. And basically, we are trying to provide this guideline or the guidebook for different stakeholders, mainly for the practitioners. And of course, it's useful for the researchers as well. And also, we plan to have like policy brief or on this. We are divided into 4 subtasks. This project is divided into 4 subtasks. So first subtask is establishing the definition, what are the challenges of the cold regions, and also looking into the definitions which are there. Then subtask 2 looks into the building envelope, the structure, like it mainly looks on the building envelope. And maybe this is something that is interesting for the Annex 94 to collaborate with. The subtask 3 looks into different energy systems, what are being used or what are there or the possibility. And then subtask 4 is looking on developing the guidelines and the guidebook and also disseminating as well. Uh, in the guidebook, we have basically 9 chapters. Uh, so chapter 1 is mainly on subtask 1, chapter 2 is on subtask 2, and then 3 is on the last section. And in this chapter 4, we have this building envelope design, and again, this is something that could be interesting for this Annex 94 activity, especially with this core region, what was being discussed just now. Yeah, the key question are building and its design can meaningfully enhance the resilience of the buildings, especially in the cold climate. And the key research priorities are performance assessment under extreme climate events. So that's very good example again for the snow that was being discussed right now. So would be interesting to have this kind of case study in the Annex guidebook. And so far, we just started this year. So we had some meetings, and this was in Iceland. I mean, the idea was to go to these regions or these kind of remote regions to have the understanding of how it is. Then we had another meeting in Narvik, which is again in the Arctic region in Norway. And we are having some case studies from Narvik, some of the buildings that are being there and being under renovation. So we are looking into these elements. So there are different challenges like mold as well, for example. This is a case study in Kiruna. So this is a city which is being, the whole city is kind of shifted. It's in the north of Sweden, and they're building a new city because the older or the current city is due to mining, it's kind of sinking. So they are making a new city or moving the whole city. So that's another case study that we have there. So there are a lot of new buildings there, and it's a very interesting place to be, I think, to look into this whole building, how they are shifting and what are the technology they are using there, especially looking into the climate challenge of snow and everything. These are the deliverables. So maybe the main deliverable is the guidebook that we are planning, and then working on the scientific publications, and hopefully are planning some summer school as well. So that's ongoing, I think, the planning. So this is the website, and we have the website that you can follow, and also we are there on the LinkedIn. So a lot of details are there. So yeah, that's about it. So if you have anything, just ask or send a message or email.
Has anyone got any brief questions for Hassam? He's joined us for this. Anyone? No? Excellent. Hassam, thank you very much.
Yes, thanks. And then there are some other cases or things, but I didn't really present because of the time. But
thank you very
yeah,
much.
we can discuss that. Yeah.
Thank you.